What do you do? What do you say? Coach Carr here, bringing you another video. This one is specifically on 30, 60, 90 triangles. And so this is another one of our special triangles, and you're going to be able to see a way to solve for each of the sides without having to use Pythagorean theorem. So I hope you enjoy. All right, so for this one, we're still dealing with the same learning target. We're trying to define trig ratios and solve problems involving right triangles. In this case, what I care more about is success criteria, and it's saying I will be successful when I know the formulas for the sides of a 30, 60, 90 triangle and can use that in real world situations. So pretty similar to the one that we had for the 45, 45, 90s. Okay, so the top of page 10 is saying, how do we arrive at a 30, 60, 90 triangle? Well, those numbers are the angles inside the triangle. So in this case, when you're dealing with a 30, 60, 90 triangle, they're not going to have the same length legs. And the side that has the longer one is going to be the one that's attached to the 30 degree, and the side that has a shorter leg is going to have the 60 degree. And this is actually something that goes along with what we learned before, because like 60 degrees, that's the bigger angle. Well, across from the bigger angle is going to be the bigger side. So that's actually something that we have learned before. Now, underneath it, it says using the ratios of sides of a right triangle with these angle measures, find the missing values given that it's a right triangle. So I'm going to draw one of those types of triangles again. And I'm going to label each of the sides like we've done with the 45, 45, 90. Now, the shortest leg is represented by x. The longer leg is represented by x times the square root of 3. And the hypotenuse is represented by 2x. So in these ones, the hypotenuse is always going to be 2 times bigger than the shortest side. Okay, so now the problem that we're looking at is number 1 on page 10. So we're going to use what we just did here to be able to solve for the different variables. Now, I'm just going to go ahead and label each of the sides like with what we have there. So the hypotenuse is what I'm going to label first because it's the easiest one to find because it's always across from the right angle. This one was represented by 2x. The shortest leg is represented by x, and then the longest leg is represented by x square root of 3. So first, we can actually find the short leg. The short leg is represented by x, and the way we're going to do it is actually by looking at our hypotenuse. Now, the hypotenuse has the equation 2x, but in this case, they already told us that the hypotenuse is equal to 10. So I'm setting it up as an equation. 2x equals 10. Now, in order to be able to solve this, next step would be to divide each side by 2. That so x can get by itself. And now I have x equals 5. So my short leg is 5. So this side is equal to 5. Now, knowing my short leg, it's going to make it so I can solve for the long leg. So we're going to be able to solve for D. Now, the equation says x square root of 3. And x is whatever the length of our small leg is. And we already figured that out, and we found out it was 5. So our long leg is 5 square root of 3. So this one is 5 square root of 3. And we can leave our answer just like that. All right, so now we're looking at number 3 on page 10, so at the very bottom. It says, given an equilateral triangle with side lengths of 36 centimeters, find the altitude length. So first thing I'm going to do is I'm going to draw this out. So if I have an equilateral triangle, all sides should be equal. So, and in this case, they told me it was 36 centimeters. Now, they want me to find the altitude length. Right now, we don't have an altitude, so I have to create it. So an altitude is going to start at a vertex, and it's going to go down and make a right angle. Now, something else to remember with the equilateral triangles is that all angles are 60 degrees. But with my altitude I just created, that cuts this one in half. So it would be 30 degrees. So with this information, and now the fact that I have a 30, 60, 90 triangle, I can find my altitude. So just a few things to remember. The hypotenuse is represented as 2x. The shorter leg, which will be right here, is going to be represented by x. And the altitude in this case, or the longer leg, is going to be x square root of 3. So now, let's get to work. It says that the hypotenuse is 2x. So I'm going to be able to find my shorter leg here. So 2x equals 36. Now I want to get x by itself, so now I'm going to divide by 2. That's so x is by itself, and now x equals 18. So I found my shorter leg to be 18 centimeters. But what they want me to find is the altitude. So now I plug that 18 in for the x there. So instead of x square root of 3, I now have 18 square root of 3. So it would be 18 square root of 3 centimeters. Now, if I was to put it into a decimal form, if I did 18 times the square root of 3, I would get 31.1769 centimeters. So I would accept either answer if you had that. All right, so now we're looking at page 11, number 4. It's saying the altitude of an equilateral triangle is 18 inches. Find the length of a side. Well, first thing I'm going to do is draw this out. So if you have an equilateral triangle, usually all the angles, well, not usually, always, all the angles are 60 degrees, and all the sides are equal. Now, because I'm drawing an altitude, so it's going to start at a vertex, go across, and make a 90-degree angle, that's going to make it so this angle gets cut in half. Now, they told us that the altitude, so this line that we just created on the inside that has a right angle, is going to be 18 inches. So with that information, I need to find one of the side lengths. So in case you forgot from the ones that we did earlier, the hypotenuse is represented by 2x. The shortest leg is represented by x. And where we have 18, that's represented by x square root of 3. So right now, the one that I have is the longer leg, the one that's represented by x square root of 3. So what I want to do is do x square root of 3 equals 18. This is so I can find what x equals. So I want to get rid of the square root of 3, so what I'm going to do is divide by the square root of 3. That makes it so it cancels out right there. And now you have x equals 18 over the square root of 3. Now I do not want a radical in the bottom. You can't have that in the denominator. So what I'm going to do is multiply the bottom and the top by the square root of 3. So now this is going to make it so x equals 18 times square root of 3 in the numerator, and then square root of 9 in the denominator. Now, again, you can't have the square root in the bottom, but because now I multiplied it by itself, that makes it so square root of 9 is a perfect square. So what we have, I'm going to continue it up here, is 18 square root of 3 over 3. So what I can do now is divide 3 into the 18. So 18 divided by 3 is 6. So I have 6 square root of 3. That is what my x can equal. So I can keep it like that, or I can turn it into a decimal. So if I made it into a decimal, then I would get 10.3923. So for my short leg, it could have been either one of these answers. So I'm going to show you both answers that would be acceptable to find the actual side length. So the side length has to be the full length, the hypotenuse, 2x. So the equation is 2x. So one way I could have it is 2 times 6 square root of 3. So if I did it that way, I would get 12 square root of 3. That would be one of the answers. And in this case, that would be inches. So 12 square root of 3 inches. The other way is I had this other answer of 10.3923 for x. So I could have done 2 times 10.3923. When I do that, I get 20.7846 inches. Both of these answers would have been acceptable. All right, so the last problem I'm going to do with you before I have you do your exit tickets is page 11, number 8. So this one, you're trying to find the missing variables. And if you notice, you have a 90, a 30, so that makes this degree 60. So I'm dealing with two 30, 60, 90 triangles. Now, what I'm looking at is the only one that I was given a value for is 10 square root of 5. This is our longer leg. So the formula for the longer leg was the x square root of 3. The y is the hypotenuse, that's our 2x. And the short leg is just x, so I'll just keep it like that because it's already there. So what I want to do is I'm going to go ahead and try to solve for x first. So if this side length is 10 square root of 5, it's supposed to be equal to the equation x square root of 3. So next step would be I want to get rid of the square root of 3. So I'm going to divide each side by the square root of 3 to get x by itself. So now you have x equals 10 square root of 5 divided by the square root of 3. Now, like problems that we've done recently, I know I cannot have a square root in the denominator. So what I want to do is multiply the top and the bottom by that square root. So both the top and the bottom are going to be multiplied by the square root of 3. When I do this in the numerator, this square root of 3 is only going to affect this square root of 5. So now I would have 10 square root of 15 in the numerator, because the 3 multiply with the 5, because they're both underneath a radical. Then on the bottom you have the square root of 9. Now, whenever you multiply it by itself, this radical, it makes it so it comes out to a perfect square. So square root of 9 is actually equal to 3. So I'm going to continue everything right over here. So 10 square root of 15 over 3. Now, I cannot do anything with this anymore because 3 cannot go into 10. So this could be my answer for x. That's what x equals. I can leave it like this, or if you wanted to, you could turn it into a decimal. So if I put this into my calculator, I would get 12.9099. So both are acceptable when I'm trying to solve for x. If it were me personally, I would just keep it like this, because this is just one extra step. All right, so that was to find x. Now let's find y, the hypotenuse. To find the hypotenuse, that's supposed to have the equation of 2x. Well, now we have actually solved for x, so we can put that in. So 2 times 10 square root of 15 over 3. So that would mean this answer would then, because this can only combine with what's not in the radical. So I would have 20 radical 15 over 3 equals y. And if I wanted to make that into a decimal, if I put that into the calculator, I would get 25.8189. So both answers are acceptable, but again, I would probably keep it with the radical in there, just so I don't have to do that extra step. That does it for another video. Thank you for watching. Make sure to do exercise number 6 and 7. 6 is a little bit easier. 7 is a little bit more challenging. If you have any questions, please just let me know. But again, thank you. Ring that bell, get that notification, and like and subscribe.